My name again is Tim Bruchman. I'm the Business Development Manager. And sorry, some of these slides maybe you saw during Dr. Sim's talk yesterday, so I'll kind of go through them quickly. But a little information on Spectral Instruments. It's privately held. We were founded in 1993 by Dr. Gary Sims and Keith Copeland. The facility we're in now, we moved into in 2002. It's on about 3.5 acres, just west of downtown. It was actually custom built specifically for our manufacturing and engineering needs. We have about 4,000 square feet and 3,000 feet of a clean room space. For those of you that like Google Maps, here's downtown, here's St. Mary's, so we're right there. Let's get right into our products. Really what our core competency is: low light level, very precise light measuring. We're using CCD or charge coupled devices and CMOS cameras. Our core competencies and our real sweet spot is very low noise, high sensitivity, and we cool all of our products. That's to reduce what's called the dark current. And then we also have very exotic products, which we'll mention in a moment. We call them Mosaic, using multiple sensors. We have applications from astronomy, which is probably where we're best known, high energy physics, biochemistry, and titer plate and live animal, which we'll talk about in just a moment. We also develop image sensors and design them. Besides using commercially available, fiber optic bonding is one of our core competencies. And then we also have an excellent OEM capability. So please, those of you out there that have a need for a very accurate and precise and high performance imaging system, please feel free to contact me. Some of our known customers, of course, we got the U of A. We have many systems up there and up on Mount Lemmon with the Catalina Sky Survey, but a variety of international customers. Here's some of our OEM customers that we've had in the past. And then as you can see from our research customers, we're very heavily partnered with Lawrence Livermore National Laboratories, Los Alamos, Berkeley. Of course, we're also in the aerospace with Goddard, NASA Goddard, and Lockheed and Northrop. And Pantex is actually a company that takes care of our nuclear stockpile. We have many systems there, and universities, of course, the U of A, and then observatories around the world. Our most exotic and most expensive product line is what we call the 900 and the 1400. Those are Mosaics. They can be anywhere from 2x2 all the way up to 4x4 CCDs. And they get very expensive because of the fiber optic as well that we usually bond to them. So again, very high precision, low noise, 16-bit readout. And then they're used in X-ray crystallography, mainly medical imaging, non-destructive testing, and X-ray inspection. Here's a picture of some of the applications for those products. Our 1000 camera is a legacy camera that's used mainly at Lawrence Livermore for streak tube readout. Here's the NIF, or National Ignition Facility. We've partnered with them since the beginning of the company in 1993. They're one of our largest customers. And also we've developed many products with them. Our real flagship product is what we call the 1110. This is the cryogenically cooled camera that handles the very large CCDs. We cool them to minus 110. Astronomy is really the main application. That's what's great about this job. I get to travel to places like the Canary Islands. That's where Gary Sims, to my right, on the left there in the center. Gary and I were pre-COVID at the GTC, or Grand Telescopio Canarias, and we have one of our cameras right there. The 1600 and 1700 camera, these are the ones that Gary spoke of yesterday, so I won't get too much into them, but they were developed for radiation environments, again, in collaboration with Lawrence Livermore. The RVT100, in addition to being radiation tolerant, is also vacuum tolerant, which is very unique. We're really not finding any other product like this where people need a camera that will survive in vacuum and not degas and cause problems with their other instrumentation. Our 1900 series platform is actually our newest camera that is replacing many of the legacy products like the 800 and other cameras that we've had in the past that have been out there literally for 27 years. So it's the same physical size as some of our legacy products. It's very versatile. We can put anywhere from a 1K by 1K up to a 4K by 4K CCD. Probably most important is we can cool it now from minus 20 to almost cryogenically cooled. It can either be liquid or air cooled, and actually Melanie Pietris will talk about our imaging division and how they're using the air-cooled options. Again, fiber optic bonding, and it can be used for X-ray, near UV, visible, etc. Here's some examples of some of our custom products. We also, OEM, that's one of our core competencies, and one of the things we're really, really good at is working with customers with specific cameras for their application. We can customize them. Briefly, these are some of our other sister companies. Direct Electron does X-ray, electron microscopy imaging. Melanie will be speaking in just a couple minutes about our Spectral Instruments imaging division. Then we have those large mosaics are used at Rayonics in Evanston, Illinois, just outside Chicago. You can see the large mosaic arrays there. So our future developments is we've used some of the technology from the Direct Electron to make a very fast CMOS camera, 40 frames a second. For an 8K by 8K, that's a lot of data. So it's not only a great sensor, but we have an excellent system of software and hardware to handle that fire hose of data. And again, we're getting more involved in this CMOS because we see that's where it's really going, the market's going. So I thank you very much. If you have any questions, here's my email. Please feel free to contact me.